Hello and welcome to video 3, the final video on Intro to STATA 16 on AU apps. In this video, we're going to talk about how to run a correlation, run a simple OLS linear regression, run a multiple linear OLS regression, how to access help files, and how to export the results out of AU apps onto your local machine. So going back to STATA, we left off with our t-test. We're going to go ahead and look at what's the relationship of GDPPC and corruption too. So is it a negative relationship? Is it a positive relationship? And is it statistically significantly different than the null? The null being that there is no relationship. So I'm going to go ahead and run a core. The correlation is our two variables, GDPPC and corruption too. You only want to pay attention to this bottom cell here. The ones is just the correlation between the variable and itself. So looking at this, the correlation coefficient is a measure of association between two variables. The sign indicates inverse or negative versus proportional, directly proportional relationships. 0 would be a non-relationship or zero relationship. Effectively, there is no relationship. While a 1 is a perfect positive relationship and a negative 1 is a perfect negative relationship. Now here we see a negative 0.89. That is a strong negative relationship, but we don't have any test to see can we reject the null being that there is no relationship. So to do that, we're going to use PW core with the option sig. That's going to print out the statistical significance test here. Our p-value is less than 0.001. We're going to reject the null in favor of the alternative that there is a relationship. Now, we never actually test the alternative relationship, though, or the alternative hypothesis, actually. So what we're going to do now is we're going to run a linear regression. So we're going to go ahead and use regression. We're going to regress GDPPC on corruption 2. We have our ANOVA table for our regression, our omnibus test. We have 151 observations. Thinking back, we had missing data, so it's using list-wise deletion. If there's missing for any of those variables in our model, it's going to omit that country. Our omnibus regression is statistically significant. We're able to account for 80% of the variability of our GDPPC by using corruption 2. But we're really interested in our coefficients. So our constant, that's our intercept, knowing nothing about a country's corruption 2. Our best guess is about almost 40,000 for GDPPC. For each unit increase, if I'm going a 1 corruption to a 2 corruption, a 2 to a 3, and so forth, there is a reduction in GDPPC by 4,761.49. It is statistically significant looking at the t and the p-value. And since we can't fit a 0 in our 95% CI, we know it's statistically significant. So I'm going to go ahead and rerun our scatter plot just as a quick visual. So going from a 2 to a 3, there is that reduction of 4,761. That's our rise over run, that's our slope. If we were to write an equation, we would say our estimated GDPPC equals our constant plus negative 4,761.49 times corruption 2. That's our regression equation. Now we can also make this a multiple regression by including literacy in there too. So now we have multiple predictors. We see a reduction in our number of observations because again we have missing values now for literacy. So now our sample size is quickly diminishing. It is statistically significant still. Our R-squared is about 70% of the variability now. And because we have multiple predictors, we want to look at our adjusted R-squared. As you increase predictors, this is a way to remove any potential inflation in our estimate. Now looking at our coefficients, corruption is still having an impact, but not as much. Our best guess is now closer to 22,000, almost 23,000 for the intercept. And literacy, as we increase literacy, it's actually the economy is doing a little bit better. What you can also do is I'm going to add the option on line 102, I'm going to add a comma and type in beta. And this tells us the standardized coefficients. So for each standard deviation increase in corruption 2, there's a 0.69 standard deviation decrease in GDPPC. For each standard deviation increase in literacy, there is a 0.27 roughly standard deviation increase in GDPPC. This also lets you know kind of the credit, or how much credit each one could have, or how much credit was given in the creation of the synthetic. Now, we'll talk a little bit about how to make things more efficient for working with STATA. So when you're in the command window, if you click on the arrow up button, now we have been using a do file, so it's not going to be active here. But let's say that we have, because we're using a do, we don't have anything in there. But let's say we did a tab OECD. If you press the arrow up button within this, sometimes that works. Because we're on AU apps, I guess that's not a feature, so I'll have to update this. If you click on, let me minimize this a little bit here, move this here. So we can actually go ahead and we can pull previous ones by just kind of clicking on it. So that's a good kind of trick you can do with this. If we're doing, let's say, tab, and you don't want to write the variable, you can also go ahead and do something like, and click on this, and that'll go ahead and enter in that variable there too. Now what I do is we're going to show you actually how to get things out of STATA after we talk about the help file. So how did I know what options were with regress? So you can type in help regress, and that's going to go ahead, and in a separate tab, it's going to pull up the help file. So it's going to tell you the syntax, how it needs to be written, and then all the different options. Here's that beta one I used. It gives you explanations of the model, different reportings, as well as examples here too. So it's actually using the sysuse is going to open up the auto data that's embedded within STATA. So you can actually use things like robust regression estimates, so forth, robust standard errors, bootstrap, jackknife, some really great stuff. You can also do that same command on, let's say, help summarize. And that gives you all the different options there too. So it really helps when you're first learning STATA. What are some different options in there too? Now let's say that you wanted to get all this information out of here. What I do now is going to install what's called an adu file. An adu file is essentially a STATA macro. When I use ssc install as.doc comma replace, this is going to install the as.doc adu file. And what we can actually do then is we can say, okay, as.doc core, so correlation table with decimal points at 2. When we do this, it's going to go ahead and there's our as.doc, and now says, no, that did not find this. That's okay. Because now it's created it. So if you click here, and on my local machine, I have the same Word doc. It's now provided in a Word document, that correlational matrix. So I'm going to go ahead and close that. You can also, let's say, want specific descriptive statistics. Let me go ahead and move this around a little bit. So I'm using as.doc, I want tab stat, and I'm going to want descriptive statistics, specifically the n, mean, median, and standard error around the mean. So here is our median, our mean, the number of values that we have for each country, and it's added it to our document again. So if I open that document on my local machine, here's our first page. And here's our second page. We can also do is we can save a backup copy of the data set. So let's say we save this, we want to save a copy of this for now and come back to this later. So you can type in save, give it a new name, .dta, and do comma replace. And then we're going to save it. So I'm going to go ahead and close some things out now. So I'm going to go ahead and close all the STATA windows. Let me go ahead and close this PowerPoint. Let me close that down too. And I'm going to drag over a couple of files. So we have our graph we made before. We have, this is all my local machine right now too, because we've saved and changed our working directory. That file with all the correlations and summary statistics in a Word document. We have our backup data set, and that STATA log we first made when we started this whole thing. So everything we've ran, all the code, all the results have been entered into a TXT file. So this is another workaround too, since we can't copy and paste on AU apps. Well, this concludes the last video on Intro to STATA. Hope this was helpful. And I do want to mention a couple of quick resources. One of my personal favorites is if you go to UCLA, Hydra, and STATA. If you type that into Google, this is a fantastic resource. They have STATA learning modules. They also have, if you click on Software STATA, they have data analysis examples and annotated output. So if you're interested in a specific type of analysis, they have walkthroughs of how to do the code with the example data, as well as how to interpret these as well. This is a fantastic resource. Thank you and have a good rest of the day.